Hi, I'm going to talk to you for the next few minutes about retrieval-augmented generation and iris vector search, which we've recently added to InterSystems IRIS that really works well within this retrieval-augmented generation application pattern. It really allows you to marry your data with large language models to make sophisticated applications. And we're making it really easy by putting this right into the database, right where your data already lives. So how does it all work? So you can see here you've got several kind of components, right? You've got your chat interface. This is the application you want to build. You've got a large language model that you're going to feed your data and you want to get answers out of. And you've got a bunch of content, right? You've got your intranet, maybe you've got some documentation you want to use that you want your chat bot, your chat interface, to really be smart about. So the first thing that you do with all of that information, that intranet content and those documents, is you build a knowledge base and you split it up into little chunks. All right, these are bite-sized pieces of information that represent maybe a single concept or a single part of your information. And that's a really easy bit of information for a large language model or for an embedding model that we're going to talk about to understand and provide like a short kind of summary, essentially, of that information. So that brings us to the second step. What you do with all of those little pieces is you vectorize them, which means you run them through a special kind of large language model called an embedding model. Embedding models come in all shapes and sizes, and one thing that they do is they take some unstructured data, which in this case could be text from documents, and they output a structured data element called a vector. It could be many elements long, could be 1,500 elements long or 384 elements long. And what that embedding model and what that vector represents is the meaning of that little piece of information. It is the meaning, it's a point in a high dimensional space that represents that meaning. And so the way that you manage these typically is you use a vector database. So after you get, for each one of those chunks, you get a vector, and that represents this point in that very large embedding space that I was mentioning. And you do that for all of your data, all of those chunks. And then that makes it something that you can just search with using nearest neighbor search, using this geometric search. So now the next part of the application is someone comes up with a question for your chatbot. You do the same thing. You vectorize it, which puts it into that same semantic space, and therefore is able to, you want to do then a query over all of those other documents. So you're searching around that point of your query point to find related documents, related chunks. And those are the ones that'll be in that little yellow circle. So then what do you do? Well, these are just vectors. And so what you have to do is go back to your database of all of that content, and you get the associated content for each one of those related vectors. And you then put those into the prompt. So now your prompt, instead of just say answer the question, you say answer the question, but only use the context, only use this information that I'm going to show you below. So that's how you augment the prompt or augment your generation with stuff that you retrieved. That's how it gets to be retrieval-augmented generation. So now you have this new prompt that has all of your context, your specific data from your database, as well as the question. And that's something that the LLM can actually now provide a much better answer, instead of just a generic answer or a hallucinated answer. Since large language models typically out of date, maybe a year old from the time that they were first introduced or first started training to when they're actually released, can be many months. As well, they don't have access in their training data set to your particular data. And so we've put that now into InterSystems IRIS. And we're making it really easy to use. So your data is already there, and now you have your vector search right in your database. As you can imagine, when you have a lot of data, searching over those vectors can take a long time. So what we've just released, full general availability, is our approximate nearest neighbor index, based on a very popular hierarchical navigable small worlds algorithm that maps very well to our globals and is now fully integrated within our SQL engine. Our query planner actually takes into account these approximate nearest neighbor indexes and weighs whether or not to use them or not. As you can see, when they are being used, you can get huge speed ups. That's on a log scale, going from 500 seconds when you do a non-index query in vector space compared to less than a second with the vector index turned on. So, as you can imagine, also, we have a lot of customers that can take advantage of this. We've seen a great uptake over the last year. We've got some customers that are taking their existing applications and adding AI to it, using that retrieval-augmented generation pattern or other types of vector search or semantic search capabilities that you can build with vector search. We're also using it ourselves across our product suite. And we have some new customers that are coming to InterSystems for the first time and using vector search right away. So thank you very much for listening. I hope to see you at Global Summit. Also, I'd like to mention that we have in our Learning Services site a new course to use this retrieval augmented generation pattern and vector search to build your own application. Please check it out.